In this lesson, we're going to finish out our character movement script. All right, so in the last lesson, we set up our variables. We also set up our awake and fixed update functions, and we started to set up our move and animating functions. So let's go ahead and start off with the move function. What is this going to handle? Well, it's going to set our movement based on our input, and then we're actually going to physically move or translate that game object. And then we'll also need to set up some rotation in that. So whenever we turn, we need to call the rotating function. Okay, and I'll have that for you here in just a minute. Let's actually go ahead and make that rotating function just really quickly so that way we are ready whenever we are needing that. So let's say void rotating, and we're going to get the float LH and LV. So based on what I've written out here, you can see that the left joystick, or the left joystick is going to handle all of the turning in that. So let's go ahead and put in, let's see, we're not going to put anything in there. I'm sorry about that. Actually, yes, I need one more float here. I put in float and then LV there. All right, perfect. So let's go back to our move. First thing that we need to do is we need to set the movement vector based on the axis input. So it needs to be based on our left joystick. We're using a gamepad for this, and so I'm setting that up. So I'm going to say movement dot set, and I'm going to say LH and then comma. And you can see here that it's giving me a little bit of a hint on how set is going to work. And so it needs a new X value, it needs a new Y value, and it needs a new Z value. So looking at my player, if I select my move tool and the player, you can see that forward is Z, and then to the left and to the right is X. Y is up. I don't want my player to move up. And so in the Y value, okay, that is going to be set to 0, F. And then we're going to do comma again, and we're going to put in the Z value, and that's going to be based on the vertical position. So if we hit LV, or not the vertical position, but the vertical movement of the joystick, okay, I should say. Then we're going to end that with a semicolon. All right, so that's everything that we need there. Let's go down one more line, and now we need to normalize the movement vector. So basically, I want my player to always point in the direction that my joystick is pointed. Okay, so we'll have this movement based on one joystick. So what I'm going to do is I'm going to set movement equal to, and I'm going to say movement dot normalized. Okay, and this is a function that is used inside of Unity. So it's available to us. It allows us to get started very quickly. So we're going to say movement.normalized, and then we need to set this by the speed. So how fast do we want this to move? So I'm going to say times that by speed, and then I need that to be set to time.delta time. So that way we get speed that is consistent. Okay, it's based on time itself. All right, so we have .delta time. Let's do a semicolon at the end of that, and then we need to actually physically move the player. So this is getting everything ready. This is setting it based on the input, so we're getting that value. And then this is normalizing that value, normalizing the position based on the input. And then this is physically going to propel the player forward. So we need the player rigid body dot move position, and then we're going to move the position based on the transform dot position. So the transform of the character or the player. Remember that transform component? That's what we're accessing here, and we're actually going to access the position of that. So we're going to say dot position, and then we want to add to that the movement value. So that way it's constantly moving it forward. Okay, so plus whatever movement is. Perfect. So now we will end that, and that will move our character. Now, we could go ahead and we could hit play, we could save this and hit play, and it would give us a value back. But before I do that, I need to get some rotation in this. So now I'm going to put in an if statement. So if, and then inside of the parentheses, there are going to be there's going to be a condition, and I want to say LH is not equal to 0f. That's a float value. Or LV is not equal to 0f. Okay? So what does that mean exactly? What do I mean by that? Basically, if we are, if it's anything other than us not touching the stick, we want it to rotate. So whenever we press that stick, rotating should be activating. Okay? And now we want to set the rotation of our player. Okay? And so what I'm going to do is I'm going to say rotating, and I'm going to call that function, and I'm just going to pass in LH and LV. All right, so that's all we need there. So now let's go ahead and fill out the rotating function. Again, we could save this out, we could hit play. Now it would have a problem with this right here because it's saying, all right, I'm going to call that, but it's not going to do anything because there's nothing in the function. So let's go ahead and fill this out. It's pretty simple, it's 4 lines of code. First thing we need is vector 3. And again, that's going to hold data that's an X, Y, and Z value. And we're going to say target direction. Let me try that one more time. Target direction, this is my variable name, and it's of a type vector 3. And we're going to set it equal to a new vector 3. And we're going to base that on the left horizontal. And then in the Y value, we're going to set that to 0. And then left vertical, or LV. And then semicolon. All right. So we have just set the target direction. Okay. Just setting its value for the variable. Now we need to create the rotation based on the new vector. Okay. Assuming that the global Y is up, okay, or assuming that up is the global axis. Okay, so what that means is it's going to turn around the Y value. Okay, so let's type this in. Next one is, we're going to use a weird word here. It's called quaternion, and we use this whenever we are dealing with rotations. And we're going to say target rotation equals quaternion dot look rotation. And again, this is one of those Unity functions that is really handy. And so all we have to do is pass in 2 parameters here. First thing that we need is the forward on this. So we're going to say target direction, and then comma, and then we need to tell it what is the up axis on this. So our up axis for the player is the Y vector. So we're going to say vector 3 dot up. Okay, that's going to pass in whatever is up on this character. Okay, in this case, Y. All right, so there we have that. And then we're going to say quaternion. Got another one of those. And we need a new rotation. Okay, so every time that we are turning, we need to update that rotation. So we don't know exactly what angle that character is already rotated in. We just need to get the old rotation and then add to it. And so that's what we're doing here. So we're going to say quaternion dot lerp, and this stands for interpolate. Okay, so when you interpolate or lerp, it goes from one value to another value over time. Okay, so we're going to say quaternion lerp, and we're going to say get component dot, or not get component dot, but get component bracket rigid body, close bracket on that, and then we're going to open close parentheses dot rotation. So I want to basically rotate the rigid body object that is on the player. Okay, now that's what we're rotating. It's getting its rotation, so that is where it's from. Okay, what the value is from, and then we want it to tell it or we want to say where we want it to rotate to. So we're going to say target rotation, and then we're going to do comma and then turn smoothing. Okay, so this is based on the time that we want it to smooth, and we want to multiply that by time dot delta time because we want it to do it incrementally. Okay, and we want it to do it at a steady pace based on time. And then one more line of code. We need to change the player's rotation to this new rotation. So we've stored the value here, and we've created that, but now we need to actually physically rotate that. So we're going to get component of the rigid body, okay, that's on this object, and we're going to say dot move rotation, and then we're going to say new rotation. Okay, perfect. So we're taking what was stored here and we're rotating it based on what was stored there. All right, so there we have that. Now let's hit Control S to save this, and then we could go ahead and test this out. But while we're here, we might as well go ahead and pass in our animating function. It's 2 lines of code, very, very easy. First thing we need to do is we need to give it our variable, so it's going to be of type bool, and we're going to say running is equal to LH, and it's not equal to, as long as LH is not equal to 0F, meaning as long as we are pressing the thumbstick, then it's going to activate this, or the left vertical is not equal to 0F. Okay, so it's anything but that. So, yeah. Now let's go ahead and say anim.setBool. And what bool do we want to set? Now this is where we're accessing the parameters of that animator. So we need to tell it the string name, the parameter name that we put in there. So remember, we typed in is running, and it must be spelled exactly like this: capital I, lowercase s, capital R, UNNING. Okay, just like this. You must end with the quotations on that, and then comma, and then you're going to base that on the Boolean value of running. Okay, so running is going to be switched to true if it's anything other than 0 on the left stick. Okay, and then whenever we release that, we go back to the idle state, running is going to be set to false. Okay, so now let's hit Control S, let's save that, let's go into Unity, and now the moment of truth. So let's go ahead and select our player. We're going to add a component, and we're going to add an existing script. We're going to say character movement. Notice the speed, and turn smoothing. Those are public values or variables, and so those are accessible in the inspector. Okay, those are called exposed variables, and these can be changed by the game designer if we need to make some adjustments to the speed. So let's hit play and let's test this out. I'm going to use my thumbstick, but you'll see that it's not moving, but there is an error here at the bottom. It's saying there's no rigid body attached to the player character. For some reason I thought we did that, but I guess we didn't. That's okay. Really quickly, let's add a component. We're going to add a physics component, rigid body, and then we're going to go to our constraints. Let's freeze the position of the Y, and let's freeze our rotation on the X and Z. We only want it to rotate around the Y-axis. And let's add one more component to this, and it's going to be physics capsule collider. On the capsule collider, you'll want to change the height to 2, and then we're going to change the Y value on the center to 1, and it should look just like this. Now if we hit play, and we take our gamepad, we start to move around, you'll see that our character is now running and moving around. Perfect. So that looks pretty cool. We release that, and he goes back to his idle animation. And then you should be able to use the WASD keys as well. Pretty cool. Now the WASD is going to work just a little bit differently, but it does the job. Okay. Awesome. I like the smoothness of the joystick a little bit better, but you have options there if you want to use that. All right, so now we have that. Now the next thing that we need to do is set up our camera for the player. And so we want our camera to follow the player just like we would see in a normal isometric type view. So we'll get started with that next.